Okay, so today we're going to do half angle identities. So they are going to be a little bit different than double angle identities. So make sure that you take notes very carefully with these. I'm going to show them slowly, and I have 3 examples to get through. So definitely take out your notebooks and go through these with me. It's not something you could just watch my video on. You definitely have to take down the examples with me and just pause as you need to. As I do the examples, just pause them, whatever you need to do. Okay. All right. So here we go. Half angle identities. Okay. So for the first thing you need to know is on your formula sheet. So I want you to have your formula sheet out with you. You'll notice that some of them have plus or minus in front. So at the very beginning, you can determine if your answer is going to be positive or negative at the very beginning. And so to determine that, it's determined if it's positive or negative by the quadrant of the new angle, the new half angle. So it's determined by not by A, but by the new half angle. And you'll see what that means as we walk through these 3 examples that I have to do with you. Okay. So we're going to be finding exact values using half angle identities. So you need to have that out in your formula sheets as we go through these notes together. So here we go. Example 1. I want to know, what is the cosine of 15 degrees using half angle identities? So the first thing that you're going to do is, there's only one half angle identity for cosine, and I'll write it off to the side here. So it's cosine of A over 2 is equal to plus or minus. This is where you determine if it's a positive or negative answer. The square root of 1 plus cosine of A all over 2. So the A has to be cut in half to get 15. So you're going to rewrite this as the cosine of 30 divided by 2, because what is 30 divided by 2? We're just rewriting 15 degrees. So 30 divided by 2 is 15 degrees. So our A is 30 degrees right here. So wherever we see A in our half angle, wherever we see an A here and here, we're going to substitute in 30. So it's going to be cosine of 30 over 2 is equal to plus or minus. So first of all, it's the new half angle. So the half angle is 15 degrees. Quadrant 1, we're talking about quadrant 1. And luckily, when we're in quadrant 1, we're saying that all of the functions are positive in quadrant 1. So our answer is going to be positive. So this plus or minus, no need to worry about it anymore. Our answer is going to be positive. So now we're going to start with the square root of 1 plus the cosine of A. Now remember, A is the 30 degrees. Okay, it's 30 over 2 to get the 15. So our A is 30. It's whatever's over 2. In this case, 30 over 2. And that's divided by 2. So that's the first step, is just setting it up, plugging in your A. Now we actually have to go through and find the cosine of 30. So it's going to be the square root of 1 plus, use your triangles. The cosine of 30 is adjacent over hypotenuse. So the cosine of 30 is radical 3 over 2. And that whole thing is over 2. So far, all I did was evaluate cosine of 30. Next, this part is a little tricky, so I'll change it to blue. You have right here a fraction within a fraction. Mathematically, you can't have a fraction within a fraction. You have radical 3 over 2 over 2. You can't have that. So we need to get rid of that by multiplying the numerator by 2 and the denominator by 2. So whatever this denominator is here, you're going to multiply by that to get rid of it. And then just to make it so that you're technically not changing anything, you're just rewriting it. Whatever you do the numerator here, you also have to do the denominator. So if you multiply the numerator by 2, you have to multiply the denominator by 2. So now we have a square root of distributive property. 2 times 1 is 2, plus, you're doing, technically this is 2 over 1, so I did 2 times 1 and I got 2. Radical 3 over 2 times 2 over 1. Your 2's cross reduce. You're left with technically radical 3 over 1 if you multiply straight across, which is radical 3 over 1 is radical 3. Divided by 4. The denominator, I multiplied 2 times 2 and I got 4. I'm going to come over here. Now we know it's a positive square root, so our answer is going to be the square root of 2 plus radical 3. And technically this 4 is also under the square root, and the nice thing is 4 is a perfect square, so the square root of 4 is 2. So this is how you can leave your answer. It's okay that there's a radical underneath the radical. The best that we could do here was simplify by taking the square root of 4 here. So your answer for the cosine of 15 degrees using half angle identities is the square root of 2 plus radical 3 all over 2. All right, let's do 2 more together. Example 2. This one's going to be the tangent of 22.5. So remember, we're trying to take half of something. So what we do at the beginning is we double it. So if it's the tangent of 22.5, to get our A value that we're looking for, because all of our half angle identities have an A over 2. So we double 22.5. So when we multiply 22.5 by 2, we double it at the beginning. So it becomes tangent of 45 divided by 2. So all I did was I rewrote 22.5 as a fraction, 45 over 2. So our A is 45 degrees. Our A is 45 degrees. So now go to your tangent half angle identity and you're going to substitute in 45 degrees for your A. So wherever you see tangent of A over 2, it's going to be plus or minus. And again, the new half angle, 45 degrees, is in quadrant 1. So, I'm sorry, the 22.5 degrees is in quadrant 1. So because that's in quadrant 1, we know our answer is also going to be positive. So you don't have to deal with the plus or minus. It's going to be positive. In addition, there are 3 different formulas. So I personally don't want to deal with the radicals in that first one. So I'm going to choose to use the second tangent of A over 2. So I'm going to use this one. I'm going to use tangent of A over 2 is equal to the sine of A over 1 plus the cosine of A. I'm going to use that one because I don't have to use radicals. So in this case, I already have enough radicals that I'm going to be dealing with. So let's avoid that one if we can. So our A is 45. So wherever we see A, we're going to substitute in 45 degrees. So we're going to do tangent of 45 over 2 is equal to the sine of A. I'm following my formula. So A is 45 degrees over 1 plus the cosine of 45 degrees. So the sine of 45 is radical 2 over 2. Okay, we've done that with our other identities. You should use your special right triangles. So the sine of 45 is radical 2 over 2 divided by 1 plus radical 2 over 2. All right, we got a lot of fractions here. So we have, again, a fraction within a fraction. So the first thing I'm going to do right here, I'll circle it in red. There's this fraction here within a fraction. We don't want a fraction within a fraction. So we need to get rid of that. So we're going to multiply by the denominator to get rid of that denominator. So times 2 over 1. We're going to multiply the numerator by 2. And we're also going to multiply the denominator by 2. So whatever you do to the numerator, you have to do to the denominator. And we want to get rid of the fraction within the fraction. We want to get rid of that denominator there. So I'm going to multiply the numerator by 2 and the denominator by 2. I can cross reduce here. So I'm going to come up here. I can cross reduce. I have radical 2 if I multiply straight across, it'd be radical 2 over 1. So I'm just going to leave that as radical 2 over distributive property in the denominator because we have two terms. 2 times 1 is 2. So this one's 2 times 1 is 2. 2 times radical 2 over 2. What's nice here, again, we're getting rid of those fractions. So it becomes straight across now. We have nothing here, so it becomes radical 2. So here, this canceled out, this canceled out. We're left with just radical 2 over 1. So plus radical 2 over 1, which is just radical 2. Okay, now we have to rationalize the denominator. We have to get rid of this radical that's in the denominator. So we multiply by what we call the conjugate. I think I mentioned this before when we were looking at tangent. So the conjugate, to rationalize a denominator that also has the 2 plus radical 2, it's not just radical 2, you're going to multiply by the conjugate, which is 2 minus radical 2. And just like when you're rationalizing, whatever you do to the numerator, you have to do to the denominator. So 2 minus radical 2. You may want to pause here and just take in everything that I just did. I'm going to carry this down now so that I have enough room to do my work. So now we're going to have to do distributive property twice here. So we're going to do distributive property 2 times radical 2. So right here, 2 times radical 2 is 2 radical 2. And then you have radical 2 times radical 2. So minus radical 2 times radical 2 is technically the square root of 4, which is 2. All divided by, and we're going to do the same in the denominator. The denominator is, we have to do double distributive. 2 times 2, hold on, let me do it in a different color for you. So 2 times 2 is 4. 2 times negative radical 2 is negative 2 radical 2. Now I take this one. Radical 2 times 2 is positive 2 radical 2. Radical 2 times negative radical 2 is minus the square root of 4, which is just 2, because we're rationalizing. We're getting rid of those radicals. So now I'm going to simplify my fraction further. So in the numerator, we still have 2 radical 2 minus 2 over a negative 2 radical 2, a positive 2 radical 2. Those are going to cancel out. I'm left with 4 minus 2. So 4 minus 2 is 2. And then the last step that we can do here is 2 over 2 becomes 1 radical 2 minus 2 over 2 is 1. So radical 2 minus 1. So if you need to go back and rewatch that, take it one step at a time. Pause as you need to. Okay, I'm on my last one. All right, here we go. Example 3. This one is going to be the sine of 67.5. So we're going to find the sine of 67.5. So we're going to use our half angle identity for sine. We're going to double 67.5. So 67.5 times 2 gives us 135. Because 135 divided by 2, technically 135 degrees divided by 2, is 67.5. I'm just rewriting it to get my A value. So now that I have my A value of 135, remember we're talking about quadrant 1 still because we're talking about the new half angle, which is 67.5 degrees. So we're in quadrant 1. So the plus or minus, we're still positive here. We haven't changed. Still positive answer. All right, so now A is 135. We're going to substitute that into our sine half angle. So it becomes plus or minus. We already know it's positive because we're in quadrant 1. Is the square root of 1 minus the cosine of A. So our A is 135. Remember, our A is the numerator here of over 2. So it's 135 degrees divided by 2. Now, this is where we talk about 135 as a reference angle. So 180 minus 135 is a 45-degree reference angle. But we're talking about the cosine of 135 here. So the cosine of 135 is negative radical 2 over 2. All-star trig class, when you're in quadrant 2 here for 135, we're talking about quadrant 2. Cosine is negative in quadrant 2. The cosine of 135 is negative. So negative radical 2 over 2 divided by 2. Again, if you need to pause as I go, you can do that. Next, I'm going to simplify here. So it's going to be the square root of 1 plus radical 2 over 2. And the whole thing is divided by 2. We cannot, like I said before, have a fraction within a fraction. So we need to get rid of this denominator here in the numerator. We need to get rid of that denominator. The denominator is 2. I'm going to multiply both the numerator and denominator by 2 to get rid of that radical 2 over 2. So now if you need to do 2 over 1, you can. So we're going to do 1 times 2. I'll show you here, distributive property, 1 times 2. So square root 1 times 2 is 2. The radical 2 over 2, the 2's cancel out, and we're left with 2 plus radical 2. So this 2 here came from distributing 2 times 1, and then radical 2 over 2 times 2. We got rid of the denominator. All divided by 4. Remember, this whole thing is underneath a square root. So the numerator is going to stay the same. It's going to be the square root of 2 plus radical 2. All divided by, remember, you can take the square root of 4 because it's all under the square root. The square root of 4 is 2. So the final answer for the sine of 67.5. So that is it. The only thing is when you get to your classwork, I did not do an example like this, but I have been doing examples like this where you have to change radians to degrees. So if you see on your classwork pi over 8, make sure, my marker is running out here, but make sure you multiply. If you see something like pi over 8, you have to multiply. I'm trying to write this. Pi over 8, you have to multiply by 180 over pi first. So 180 over pi first if you see something like pi over 8. Okay? All right, good luck. Come to office hours if you need help.